Reaction set 3 will contain the last two types of synthesis reactions. In this first type, a nonmetal oxide plus water will form an acid. Remember, acids always start with H+. Nonmetals are everything to the right of the zigzag line, so things like carbon and sulfur and nitrogen. So in this case, we're going to make an acid with these reactants. And if you look on the reactant side, you have CO2 and another oxygen. That would give you CO3, which is the polyatomic carbonate. So to cancel those charges, you would have H2CO3. And to name the acid, if this is carbonate, any polyatomic that ends in ATE, when it's in an acid, you change the ending to IC, so it would be called, instead of carbonate, carbonic acid. In this example, N2O5 or dinitrogen pentoxide will form an acid, and so we have H+1 there are two nitrogen-containing polyatomics, so it's either going to go with nitrite or with nitrate. And if you look at the number of everything on the left side, you have N2O5 plus another O. That would give you N2H2O6, or if you reduce it down, it would be NHNO3. So your acid is HNO3, but you just have two molecules. And because the polyatomic in the acid is nitrate, you change the ending again to IC, and this is nitric acid. Sulfur dioxide is added to water, so we want to make our acid H+. If you look at everything else that's left, you have SO2 and another O, so SO3, which is -2. And so to cancel the charges, you would have H2SO3 as your acid. The polyatomic SO3 is called sulfite. And so to make the name of the acid, if you have an ITE ending, you change it to OUS. So, and you put in the UR just to make it sound a little better. So the acid is sulfurous acid. Water and dichlorine pentoxide are mixed. So if you put all this together, you would have H2, Cl2, O6, or if you reduce everything down, you would have HClO3. So that would be your formula, and you just have two molecules of it when you go to balance. This polyatomic is chlorate, so change the ATE to IC, and your acid is chloric acid. Sulfur trioxide is added to water, SO3. So again, if you have H+1, you have SO3 and another O. That would be H2SO4. Or if you just add up what you have on the other side, you have two H's, one S, and four O's. And so because this polyatomic is sulfate, again, you change the ending, and it's sulfuric. Remember, they add the UR just to make it sound a little better, so it's sulfuric acid. The last type of synthesis reaction is a metal oxide plus a non-metal oxide to form a salt. A salt is an ionic compound, a plus and a minus ion together. So if you look at the reactants, the only thing that you have as positive would be the sodium +1 ion. If you put everything else that's left in the equation, you've got a CO2 and another oxygen. That would give you CO3, which would be carbonate -2. And then you would just have to cancel the charges to make the compound. So your salt in this case is sodium carbonate, Na2CO3. Calcium oxide and sulfur trioxide would combine to form a salt. And in this case, again, you look for a positive ion, calcium +2. And if you put everything else together that's in the compound, you would have SO3 and another O. So that's sulfate, the polyatomic sulfate. And then you would form calcium sulfate as your salt. Potassium oxide and CO2. Potassium oxide would be your positive ion. CO2 and another O would give you carbonate. And then you would just want to cancel the charges. So K2CO3 or potassium carbonate is your salt. Magnesium oxide plus sulfur trioxide. Again, your ion, your positive ion would be magnesium +2. If you put SO3 with O, you would get SO4 with a -2 charge. And so your formula of your salt would be magnesium sulfate. And the last example is calcium oxide and P2O5 diphosphorus pentoxide. Your positive ion is calcium plus 2. And because the rest of the equation contains phosphorus and oxygen atoms, your polyatomic would have to be either phosphate or phosphite. And you would just have to try each one and see which one works when you balance the equation. If you were to try phosphate, calcium is plus 2, phosphate minus 3, you would have to go to plus and minus 6. So you would have 3 calcium atoms and 2 of the phosphate polyatomics. And then if you put a 3 in front of the calcium oxide, that would balance correctly. You would try, if you tried the phosphite ion, PO3 minus 3, you would find that the equation would just not balance. So that one's not the one that's involved. So sometimes you may have to try both versions of the polyatomic containing a certain element. On the back of set 3, you'll find practice synthesis reactions and some of the others that we did from sets 1 and 2.